video is for the Blended Algebra 2 class. We're working on lesson 3 now, which is simplifying square roots. So some words and terminology that we need to know before we can jump into the notes is what a radical symbol is. All right, this is a square root symbol or a radical symbol. That's what we're going to work with when we simplify square roots. The radicand is the number under the radical. Then it says a number that's made by squaring a whole number is called a perfect square. We're going to look at some perfect squares in a minute here. The principal root is what we're going to work with here. The principal root is the positive square root of a number. We're not really going to use that word too often, but just know that we're not, technically there's a positive and a negative square root. We're only going to be working with the positive. All right, and finally, an irrational number. We talked about these in the last lesson. An irrational number is a real number that cannot be represented as a fraction. So let's jump into what we're going to work here. We need to know perfect squares in order to simplify square roots with the method I'm going to teach you. You need to know the first 12 perfect squares. You should know what they are and how to find them by sight. So 1 squared is 1, 2 squared is 4, 3 squared is 9, on and on, 16, 25. Write the rest of them down here for you. Alright, so you can obviously use your calculator, but you should be able to look at 36 and know the 36 and say perfect square. The square root of 36 is 6. So I'm going to show you here how to simplify square roots. I'm going to show you 2 methods, but I think I'm just going to show you one method. I changed my mind. I'm going to show you both using the method of perfect squares. I'm just going to stick with one method here. If you know another method really well, you can use it, but I'm going to use the method of perfect squares. So what that means is look at 72. I want to find the biggest number from this list that I just wrote of perfect squares that goes into 72. Now, I know my factors really well, so I'm going to go a little bit faster than you might, but you can pull out your calculator and try to find these values. Okay? So square root of 72, that is the same thing as taking the square root of 36 times 2, right? 36 times 2 is 72. So I'm just going to put multiplication under the radical. Now, there's a cool rule about square roots that the square root can break up over the multiplication. So I can rewrite this as the square root of 36 times the square root of 2. Now, I chose 36 very strategically. I chose 36 because it is on my list of perfect squares and will simplify to be 6 times radical 2. And that is your final answer. Now, you can check your answer using Desmos or your calculator. And the way you would do that is this. We started with the square root of 72. That's 8.48. We simplify that to say, well, that's equal to the square root of, or 6 times the square root of 2. And you should notice that you get the same answer here, which means that those are equivalent expressions. All right, now let's try 80. We're going to use the same method, perfect squares here. The biggest number that goes into 80, you know 4 goes in, but actually there's a bigger number, and it's 16. So the square root of 80, we can rewrite it as the square root of 16 times 5. Now I can break up that square root again to be the square root of 16 times the square root of 5. And 16 is a perfect square. That's equal to 4 times radical 5. Again, you can check your work using Desmos here. We can take the square root of 80 and 4 radical 5, and we get the same thing. Excuse me. So we know we simplified accurately. Now we're just going to practice a bunch down here in the next part, okay? We have 6 practice problems. We still need to know our perfect squares. So I'm going to rewrite them here at the top. All right, here's our perfect squares. From that list, 63, the biggest number perfect square that goes into 63 is 9. 9 times 7 gives you 63. So I'm going to skip right to this part where I can break up that square root. Square root of 9 times the square root of 7 is the square root of 63. Square root of 9 breaks down to 3. The radical 7 does not break down. So you are done. You can check your answer. I'm not going to check all of these, but you can check your answer on Desmos if you'd like. Number 2, the square root of 50. Well, the biggest number from that list that goes into 50 is 25. 25 times 2 is 50. So we start with them under the radicals. Now I break down the radical that I can simplify, which is 25. That breaks down to be 5 radical 2. And then you're done. Now 3, 81. You should notice that 81 is on my list of perfect squares. That means I don't have to break this down by using square roots. I should just know that the square root of 81 is 9, and then that's it. That's your whole problem. All right, now I look at the square root of 19. The only numbers that go into 19 are 1 and 19. And I'm going to kind of ignore the 1 on this list. There's nothing else other than 1 that goes into 19, so this square root actually does not simplify any farther. That is the fully simplified form. Now don't let the fraction in the next one worry you. Just like the square root can break up over multiplication, a square root can break up over fractions. So I'm going to rewrite this as the square root of 1 over the square root of 9. Now we simplify each. The square root of 1 is just 1. The square root of 9 is 3. So 1/3 is the square root. Same thing in 6. I break up the square root over the fraction. Oops. Now, here's the thing. The square root of 5, the numerator, doesn't simplify. That stays the same. However, 24 does have a perfect square. 24 can be rewritten as the square root of 4 times the square root of 6. 4 is on my list of perfect squares. 4 breaks down to be 2 radical 6. And then you're done with your problem. That's as simplified as we can get. All right, now those aren't too bad, just simplifying square roots. But we're going to see in this unit that sometimes our square root is going to have a coefficient. 6 times radical 12. Now here, I'm going to leave the 6 out in front for now. That is part of the problem. We want to break down radical 12. And I'm going to copy that list back over. Again, right here. So we can reference it. The biggest perfect square that goes into 12 is 4. So I'm going to write this as 6 times radical 4. And 12 is 4 times 3. Now, again, that 6 keeps coming. The square root of 4 is 2, so I'm going to multiply by 2 because it's all being multiplied together. Radical 3. And all that's left is to multiply 6 and 2, which is 12. Radical 3. Now, if you wanted to check your answer, you could check by typing 6 radical 12 into your calculator and also typing 12 radical 3 into your calculator. You get the same square root, the same value for it, so you know you simplified it correctly. All right, number 2, it's the same kind of thing. Let's simplify the numerator so that we can then eliminate the denominator. 32 is 16 times 2. So we're going to rewrite this as radical 16 times radical 2 over 4. I cannot cancel the 4 with anything yet because the numbers in the numerator are under a radical, and that blocks you from crossing anything off. But square root of 16 equals 4 radical 2 over 4. Now that the 4 is out of the radical, I can cross them off and get that the final answer is radical 2. Number 3. Same thing as the last problem. Square root of 18 is 9 times 2. So I'm going to rewrite that as radical 9 times radical 2 over 2. Well, radical 9 is 3 radical 2 over 2. And I can't simplify anything. The radical 2 and 2 are not like terms, so I can't cancel them. And 3 over 2 don't simplify. All right, last problem. The negative 5, like in number 1, hangs out in front. 28 can be broken down into 4 and 7. 4 is on my list. I bring the coefficient down. Radical 4 simplifies to be 2, radical 7. And when I multiply the coefficients now, I have negative 10, radical 7, which is your final simplified answer. All right, let's flip our paper over. Let's learn something new. Up until right now, whenever we asked you to find the square root of negative 16, we would have said, oh, we can't do it. We're not allowed to take the square root of negative numbers. Well, turns out that we actually are allowed to simplify square roots that are negative, that have negative radicands. We need a new number to do this, and that number is the square root of negative 1, which is called I. I know I is a letter, but here is also a number. I is called an imaginary number. Okay? It's a theoretical concept, but I is an imaginary number, and we're going to see where I comes into play later in the unit, but for now, we just need to know that the square root of a negative is going to be I. So I'll show you how this works. If I have the square root of negative 16, if there's a negative under the radical, a negative radicand, one of the perfect square factors you always are going to pull out is negative 1. Here I'm going to rewrite this as the square root of negative 1 times the square root of 16. Now the square root of negative 1 is I. You should know the square root of 16 is 4. So I have I4, which is totally fine to leave it like that, but the convention, or the common way to do it, is that the I comes after the 4. So we would say that the answer is 4I. In B, again, I have a negative under a radical, so the first thing you do is pull the square root of negative 1 out in front. Now I'm going to break down radical 40 in the same way I was breaking down my other square roots. I look at my list of numbers. 4 is the biggest perfect square that goes into both. So I'll rewrite that as 4 times radical 10. Now, radical 10 does not break down. Square root of 4 is 2, and square root of negative 1 is I. Typically, again, we put the I after the number, so it's 2I radical 10. The more you see this, the easier it's going to be to find your answer and find the values. Square root of negative 18, again, I have a negative, so I pull out the square root of negative 1. I will have an I in my answer. 18 can be rewritten as square root of 9 times square root of 2. 9 is a perfect square. Again, the square root of 2 doesn't simplify, but the 9 and the square root of negative 1 do. Square root of 9 is 3, and the negative 1 gives me an I. So therefore, I have 3I radical 2. Finally, in D, we're going to rewrite this. Square root of negative 1 times, well, notice radical 144 is on our list. So that is a perfect square that I can simplify. The square root of 144 is 12, and I'm going to put an I on the end for the square root of negative 1. All right, we have a couple more, just 4 more here of the notes, and then you can try the practice. The square root of negative 45. So let's put our list at the top so you can see it. The biggest perfect square that goes into 45 is going to be 9. So let's rewrite this. I have a negative 1 in front with square root of. Square root of 9 times the square root of 5. Those 3 numbers multiplied would give you negative 45. Now, the square root of 5 stays the same. I get an I from the square root of negative 1 and a 3 from radical 9. And that's your final answer. Square root of negative 11. I pull out a negative 1 times radical 11. Now, radical 11 doesn't break down. So that stays the same, and then I just put the I in front of the radical. And that's the whole problem. You just can't have a negative under the radical. You have to pull the I out. Now here I'm going to have an I with a coefficient. So that 2 stays there. Negative 5 will be pulled out, or I pull out a square root of negative 1 from negative 5 times radical 5. The 2 stays there. The square root of negative 1 is I, and radical 5. And that's the full answer. And finally, the last one on the notes. Our coefficients, square root of -1. Now 90, the number from this list that goes into 90 is 9 times 10. The radical 10 stays the same. I get an I and a 3 from the 9. You can't forget about the 6 that you already had. All you have to do is multiply the 6 and the 3, which is 18I radical 10. And you are all set. All right, I know those notes, the I especially might be a little bit confusing. Try the practice on the bottom. If you need some extra help, ask the teacher or check the Canvas or watch the video over again.